the overall equipment efficiency. If you're really producing something, the equipments for your production are really big assets and capital intense part, and you would like to that these parts are really working in a most efficient way. And if the measure of this is the overall equipment efficiency, it's in my opinion, a complicated number, and it depends on many different things. And if you think about the overall equipment efficiency, it's about the full time an equipment is really producing or not producing. And the first layer, we have seen it already, is all about the scheduling. I mean, if a machine is not scheduled for production, and then of course it's just standing around and it's not producing something, and then you have this kind of schedule loss. So it's very normal that some of these machines are not producing something. And this is all about the planned production time, and we had this discussion on the scheduling algorithms itself. So overall, if you really would like to optimize this part, it is a planning problem, not really a shop floor problem. But once you schedule something onto this time on a machine, then the machine is running and you're producing something. And sometimes we have a breakdown, and then you have an availability loss. So this would be really the classical thing, that something is not working and then you have a loss in availability. And then you have maybe a performance loss. So that means your entire coordination around the machines itself are not optimized. You could produce, but you still have to do something else, or maybe it's not perfectly organized around, then you have a performance loss. The performance loss can be also in the machine itself, that the machine is not running on full speed, might be as well. And finally, you're producing something, and then you have a quality loss. And this quality loss, that means your machine produced on something with a capital intense production line, and then you have a quality loss. It means the net time itself of this productivity is not given. If you look on these different dimensions, there are sometimes discussion, what is OEE overall? You have, as an analytics person, you have to think in OEE always in all dimensions. You can define your OEE against the planned production time, you could define your OEE against the all time, and there are different acronyms for this in different industries, how this is named. Still, you have to know how to measure it overall. It depends on the perspective, on the planning or the shop floor perspective. And why is it such a good case for analytics? The overall OEE, or especially the red parts here, you can really help with analytics to understand these losses. And this is exactly the wonderful cycle of data science and analytics. And maybe just as a reminder, I had this in other lectures, the root cause understanding or the root cause analytics, it's a wonderful topic for OEE analytics. And with this so-called CRISP cycle, it's all about the business understanding. Then you extract the data, you want to understand what is all around in your machines, and then you're doing the modeling, evaluation, and it is always an iterative process. You cannot solve or improve the OEE in one shot. You're doing one analysis and then it's done. You have to work together with your shop floor people, with the people really on the machines to understand what's happening there. Maybe you have to work together with your engineers really producing the machines, and this kind of cycle is here depicted as a cross-industry standard process for data mining. It's really old cycle, but in this case, it's really a wonderful approach really to optimize your OEE. And what kind of mathematics are you using in the background? Now we're entering really the world of machine learning, not to predict something, this will be predictive maintenance later, but the root cause analysis is all about so-called feature engineering. So what is it? So you're collecting all your data on the machines, and maybe you have really a kind of inefficiencies on your shop floor or in the machines itself. And then you do the so-called feature engineering, you pack your data together, and a machine learning algorithm tries to understand which impact has, which part has the most impact on the overall problem. And this is depicted here in a graph on the right side. You get then on different impact factors, you get really the most important parts first, and then you are going back to your knowledgeable workers or to the engineers and say, look, we believe that this is a root cause. Then sometimes the experts will say, no, this is not true, because here it was on purpose that we switch it off. It was on a maintenance cycle and so on. And then you extract the first feature and you go to the next one. And you really embed your work, your analytics work, really in finding towards the root causes of this OEE overall. And this case is really, really mighty and underestimated on the shop floor level. To do this kind of machine learning exercises on the machines is really the first step also to predictive maintenance, because often you have challenges that you cannot access all data sets. Sometimes the root cause are maybe with a wrong handling of a person. How would you really track this kind of information? And you start really digging into the true world of production and all environments around. The root cause can be so manifold on different production sites. It's really a fantastic work to go in and really understand all data assets which you need there. And it's not only about sensor data of your machines. It's really, how did you schedule it? Where are the resources? So all secondary data you can imagine on the production floor, you need there to understand the full OEE cycle. And you have to ask really precise hypotheses what to check for. And this is exactly where this CRISP cycle is coming in, where you really precisely define one topic and then try to analyze this topic and then go one step further. You cannot analyze a full OEE cycle in one shot. It's really an iterative approach, but it's a wonderful approach, and typically people really like in this form with you together to do the analytics together with a process or engineering experts on the machine itself, and you can really find wonderful things. And once you have done this in a very, very good way, then you are entering the world into predictive maintenance, where you really try to predict if a failure will happen. But first you should go into this OEE improvement.